All right, hello everyone, and welcome to my DevSecOps, an inclusive community that educates and enables developers in application security. Coming up, we'll be joined by Gareth Rushgrove. Hey Gareth, how's it going?
Hey, good, thanks.
Awesome, thank you for joining us. Gareth will be speaking about the perils of configuration security. Short introduction for Gareth before he does his own. Basically, Gareth is a director of product at Snyk. He has previously worked for the UK government, Puppet, and Docker. And I don't know when he finds the time, but when he does, he also runs the DevOps Weekly newsletter. But before we dive into all of this, just a quick intro on myself. My name is Rontel. I'm a developer advocate at Snyk. We'd love to hear any feedback you have, so we continue to improve. So if you have anything, just shoot us on Twitter or search the My DevSecOps channel on the Slack group. The Slack group itself is actually the best place to contact us if you have any speakers you want to reach out to or just ask questions. We're all there to try to learn from each other. So go ahead and also join us on the live sessions channel so you can ask Gareth some questions at the end of it. If you're listening to this after the live session, so this is a recording, but you can still go on the Slack channel and reach out. Once the session is over, you can rewatch it, and share it with friends. My DevSecOps is brought to you by Snyk. Our aim is to create a vendor-neutral space to share knowledge and best practices related to software security. So that's enough with me and all the heading up. Without further ado, I'm going to move it over to Gareth to welcome you into the session.
Well, thanks a lot, Laurent. So I'm going to talk about the perils of configuration security. Who doesn't like a slightly overblown title? So as Laurent mentioned, I'm Gareth Rushgrove, based out of Cambridge in the UK. I work with Laurent at Snyk. I think partly some of the things I'm talking about are things I do further afield as well. So I've been involved in the DevOps community from just around the coining of the term, just a little bit afterwards. And I run the DevOps Weekly newsletter. I'm also actively involved in a bunch of open source projects, probably most recently Open Policy Agent, which I'm going to talk about a little bit. So what can you expect from this talk? I'm going to do a bit of an introduction to configuration security. It's not necessarily two words you often find together, even if they're two words you probably use a lot individually. I think bringing them together is sort of interesting. I'm going to touch very briefly and hopefully without causing any religious fighting on static analysis. Always gets some people interested and others angry. I'm going to bring two examples really in this sort of conversation around configuration, specifically talking about Kubernetes and also then talking about Terraform. We'll look at the what sort of security problems you see in them from a configuration perspective. We'll also look at a few tools, and mainly from the open source community, around helping you address them. And then we'll sort of wrap up with probably a few overbroad points and see where we go from there. All being well, we should have some time for questions as well. So if you've got any questions, do leave them on the channel. Lauren will ask them, or we'll head over to the Slack channel afterwards. Okay, so configuration security. Starting out without the security side and just talking about configuration, I guess one of the things we've definitely been seeing over the past maybe sort of 5, 6, 7, 8 years, I guess really, is this move towards infrastructure as code. It predates that, with CF Engine, with Puppet, with Chef, but I guess this is becoming a lot more the norm now. So whether it's your all-in on Kubernetes and you're writing a lot of Kubernetes config files and you're writing too much YAML, or whether you're actually all-in on serverless framework and writing YAML, or whether you're using Ansible and YAML.
Gareth, can you really write too much YAML, or is it never enough?
I definitely feel you can. At least by hand. I'm much more of a fan of generating your YAML from higher level languages.
What could go wrong?
But yeah, Terraform, not YAML, HCL. It's fantastic. We'll talk about Terraform in a bit. But ultimately, there's all this explosion of tooling around helping you describe your infrastructure in code. I made all the YAML jokes before, but it's not just me, honest. Even Brian Cantrell would agree. I mean, ultimately, it's everywhere. And we're increasingly seeing configuration being written by developers in source control repositories. So if you look at even just publicly on GitHub at the moment, there are more than 2 million sort of Kubernetes shaped config files. There are like millions of Docker files, hundreds and hundreds of thousands of compose files and Terraform files. And remember, this is public. This is not, like, most of the time when you're describing your infrastructure, you're not doing it in public, you're doing it in private. It's your private infrastructure. But this is all public. So this is the tip of an iceberg. And ultimately, the amount of code we're writing to generate our infrastructure, manage our infrastructure, manage our applications is increasing. The downside, unfortunately, of this is that this poses a risk. Ultimately, this isn't a new risk. It's not that because we're writing our configuration in code, we have potential security problems. The problems were there in our systems as they were configured before. They were often magically invisible because we configured them via pressing buttons in web forms or on thin clients. The configuration actually was only on the host, on the machines. So this is actually a good thing, but it doesn't mean there's not security problems in the code we're writing to configure our infrastructure. So a good example of this was the Capital One recent breach. And they said, well, actually, yeah, this was a configuration vulnerability. And again, I think adding those two words together was really interesting. I'm a config geek and a security geek. And the idea of a configuration vulnerability is definitely something I think that resonates with me. It's nice to have language around problems. Rapid7, another sort of security vendor, does a lot of work with penetration testing with customers. And they said, I mean, this stat was sort of like 96% of the work they do, they detect some misconfigurations resulting in that could result in a security problem. So basically, most configuration is insecure. Again, whether it's that insecure or whether it's higher actually, or whether it's a bit lower, this feels plausible and feels right based on my experience. And a recent report that's definitely worth reading from the NSA actually stated that while cloud service providers often provide tools to help manage configuration, misconfigurations of cloud resources remain the most prevalent cloud vulnerability. And the idea that the cloud is a security risk actually, for the most part, isn't true until people start using it and the people using it introduce those problems. That's actually pretty much what happens with most software. The cloud is no exception. So if we're seeing a lot of configuration ultimately shift to being in code, that actually does mean it's in source control systems. It's often been written by developers or people who are close to developers. And that configuration can result in a sort of a type of security issue. What can we do about it? Well, one of the areas I think that's interesting is good old static analysis. So quick definition, really. Static analysis is defined as static program analysis is the analysis of a computer software that is performed without actually executing the program. The upside here with regards to configuration in particular is that executing that program might result in you firing up expensive infrastructure. Also, that provisioning virtual machines, even launching containers at scale, whether that's via a serverless interface or it's something else, provisioning a database, whatever it might be, can still be time consuming. And so adding the sort of time and cost complexity, static analysis has its benefits. It has its detractors, often down to sort of a false positive and false negative issue. There are some reasons why that's less of a problem in configuration that I'll come back to. So I guess often if you're writing an application, you might have acceptance tests and integration tests and unit tests. Again, some of these words end up being used differently in different language ecosystems or in different companies or organizations or frameworks. But broadly speaking, like there's often this progression. Static analysis is often used first, especially where it's done right in the sense it can be really fast. This is not always true of all programming languages. Ultimately, some languages are actually really fast executing, but analyzing them because of their inherent complexity is actually really computationally expensive. Sometimes if you're trying to do it in the same language, you end up with paying that performance penalty twice. So this is not generally true. However, one of the advantages of as mainly using declarative languages for configuration. So YAML is ultimately data, but HDL is a configuration language, or Puppet is a configuration language. Others, they're not exclusively, but often have a number of properties that make them fast to analyze. So that declarative nature, often they're not Turing complete. This can allow actually static analysis to be very fast compared to other testing approaches, especially compared to like when you're actually spinning up infrastructure, you're actually executing the program, because then you're bringing in not just the network to someone else's computers, but actually the network to someone else's hypervisor and control plane to provision other computers. So for configuration and infrastructure as code, static analysis can be both faster than it is often the case in more complex languages, but also acceptance testing can be much slower. So you start getting more benefit out of analyzing things earlier. I mentioned that sort of declarative languages ultimately lend themselves really well to static analysis. I think I had this originally as like heart static analysis, and someone said, well, and I think that's fair. But I do think adding that declarative configuration to static analysis is a good starting point. I'll show you some tools which actually take that idea and run with it, and I'll show you what I mean in a second. I'll do that through the lens of a couple of different, if you like, ecosystems. Again, there are lots of different areas where people are using different configuration tools. I've just picked two here. I think looking at two is useful, probably more useful than just looking at one. And I've picked two that I'm reasonably familiar with, but we could jump it around as well. So Kubernetes is probably something lots of people are familiar with at this point, whether they're using it or not. And ultimately, Kubernetes configs are getting increasingly common as well. So if you're wanting to deploy your application to Kubernetes, you've probably written or seen something like this. So this is a deployment manifest for Kubernetes. It's described in YAML. You can use other formats and other higher level languages, but we'll leave that outside for this. And as I mentioned, there are a lot of these, literally just publicly on the internet, never mind elsewhere. It's definitely been the sort of a growth sort of tool. So, and what we're showing here is obviously a deployment. It has a name, it has some replicas. It has a bunch of sort of metadata and some template information. I say obviously, but I've been using Kubernetes for a number of years. If you haven't, then you look at this and go, well, I don't know what's going on. Or you might be able to like go, well, yeah, replicas, there's going to be 3 of them. You might not know what replicas are yet. You might have an idea, but we know there's going to be 3 of them. The issue there is that configuration file I showed you, again, that snippet of one, actually had a number of configuration issues. A number of configuration issues that could lead to security problems. Now, just looking at it and seeing them is probably beyond most people. Certainly, I would miss things, and I've been using Kubernetes a long time. This is definitely a job for machines. Some of the issue here, and this has been discussed quite a bit in the Kubernetes community at the moment, about actually making Kubernetes more secure by default. But there are still a lot of insecure defaults around. Some of those are for good reasons. Some of them may be historical ones. But a few examples are actually resource limits. By default, if you run a container as part of that deployment, it basically has access to the resources of the host. It can run with as much CPU memory limits as it can get away with, and the cluster will schedule it around. The issue there is, from a security standpoint, one of denial of service. And that actually can be an operational one in terms of it might just be a denial of service because it's bad code and it runs with too many resources, and it's actually an internal issue rather than a security one. But actually, from a DDoS perspective, if you can find something running without limits, there's a chance that you can start saturating the host or the nodes. So running with like memory and CPU limits, like putting some bounds around things, is a good security practice. In the example, well, I didn't have limits set. The rather confusingly named run as non-root, which you set to true, in order to run as non-root, which is like all about whether the actual container running has root level permissions. Ultimately, by default, it does. You need to set these settings in the security context to change that around, or change the cluster defaults, which most people don't go ahead and do. So finding deployments that are ultimately running as root is surprisingly common, because people don't think about the fact that they need to add something in order to change that. Similarly, read-only file systems. Again, that's if you've got a writable file system, if someone can get run a command on that machine via some exploit or get a shell on there, well, they can write to that disk. That disk might be virtualized, it might have access to other things. Like ultimately, you have the fact that they could drop malware in that container. Yes, there's issues around that being persistent, but you still don't want people finding an exploit and being able to change files on disk, especially if they might be shared. Having a read-only file system prohibits that. It's a common security precaution in any sort of operating system level sort of security. Enabling that in Kubernetes is actually really simple. You just put read-only root file system true. However, in order to do that, you need to know this exists and do it, both of which are actually not the default. And as another example, the idea of like exposing Linux capabilities. These are the low-level system calls that Linux provides access to actually do things like connect to the network and write files to disk. Again, they're a fantastic security control for any Linux operating system. Containers expose those. The default is ultimately you have access to all the capabilities. By dropping all of them, you ultimately enter into that least privilege mode. Now you have to add everything back. It can be verbose. It does mean you need to understand this low-level component, but it does mean, for example, you can have containers which don't need access to the network, literally at the Linux capability level, unable to access the network. It's a great security control, but it's easy to ignore or miss, partly because it's low level, partly because, again, the defaults are everything's wide open. So there are a number of challenges when writing Kubernetes configs, especially if you're a new user. And you shouldn't be able to be expected to be expert in such a large domain so quickly, even if writing that hello world first deployment is actually really simple. The good news is there's a few tools that might be able to help. Again, there's always tools sort of emerging. One of the first ones was definitely CubeSeck from the folks over at Control Plane. So they make this available both as an API online, as well as a command line tool you can run against your configuration files. And it has a number of rules set aside for some of the problems I just highlighted, as well as others. It's reasonably popular. It's been around for a few years. I don't see as much use of it as I might expect, but maybe I'm more interested in this particular problem than others. Another tool that I will disclose my bias here, I'm one of the contributors to and work on, is actually ConfTest. The ConfTest is a little bit different in that it's a sort of not exactly a static analysis tool as much as a unit testing tool for configuration. It allows you to write your own tests against structured data. That structured data might be YAML files or JSON files. It could actually be HCL or Q or TOML or XML, in fact, even. So it's really flexible for writing tests against any configuration, not just Kubernetes. But a lot of the usage at the moment has been around the Kubernetes community. Increasingly popular, and I say this, I was one of the, well, I created this originally. There's now a core set of maintainers who are doing most of the work, frankly. This started about 10 months ago or so. Again, the upsides of flexibility, downsides of you needing to write your own rules. But we'll get into some ways of avoiding that in a second. Confidentiality is actually built on top of Open Policy Agent. So Open Policy Agent is a generic tool for basically policy enforcement. It's a policy engine as a library. If you've ever written sort of, I guess, complicated code in the middle of something that makes assertions about whether something's right or not, you've probably written basically a policy engine. Open Policy Agent is that engine, but on steroids. It's basically been written solely for that purpose, generically. So then you can plug it into your different tools. It's written in Go, so it can be used natively there. There's actually a bunch of WebAssembly support, making it easy to integrate as well. But also it provides APIs if you're using other languages. It's actually one of the CNCF projects, and there's a really sort of vibrant open source community around it. It's finding its way into lots of different tools as well, which I think is interesting from a sort of reusability point of view. Confidentiality makes it easy to integrate like that sort of those testing into lots of different places. So it provides a CLI tool, but there's also a GitHub Actions, there's Tecton pipeline tasks, there's the Circle CI orb as well. It's really easy to integrate into your CI system. And tests look a bit like this. So these are not actually for Terraform and HCL, these are for Kubernetes, where we're saying, well, actually, if this is a deployment and it doesn't have run as non-root true, then deny this config file. So basically, we're flagging up that the container must not run as root. And Confidentiality itself, I say, is the simplest version. It's simply a CLI tool where we can point it at our config file, have our policies locally, and it will return those results, like what's wrong with our config files. As I mentioned, like though, you sort of need some expertise in identifying those problems. So you probably don't want to be the person on the hook to know all the things that are wrong and have to encode them in Rego. The nice thing with Confidentiality is it allows you to use third-party policies. So we can just simply point it at GitHub or point it at images on like ACR or the container registries and automatically use the policies from there. And again, so like you don't have to be an expert. There's sort of that meta question of if a unit testing tool where you don't write the unit tests, is that static analysis? I don't think it matters that much, but ultimately it behaves in a similar way. So let's see a quick demo of that in action. Let's move over to my terminal. So here I've got a Kubernetes configuration file. In fact, it's actually a multi-document file. We've got a deployment defined here with a simple hello world example and a service that will run it. This is exactly the sort of thing you would find simply on an introduction to Kubernetes. It's probably the first thing you ran when you first learned Kubernetes. The issue, though, is it has some of those security problems we mentioned.
It's easy to just pick up on some tutorials, I guess, and miss the security defaults, because you usually just start off as like, as you learn, copy paste it, put it in a microservice, and you'll figure out you'll do it later. But I guess that's where things get messy.
Exactly, but I think there's also and this is true of, I mean, all programming languages. And I think the more we treat configuration as a language with all the same pluses and minuses, the better. So if you go along and look at a simple Ruby application or a Hello World Sinatra application, it's beautifully simple. It's 3 lines. Go look at something for Express and it's 1 or 2 lines. The reality of the person who's been deploying those in production like for a few years, they benefited from that fact and that's why they got started. They were like, wow, it's 2 or 3 lines. Realistically, you know that that's not going to remain 2 or 3 lines. You know you're going to have to do some work to make it more secure. But actually, if you do, I think the flip side of that is if you just show someone a real world application with not just the security things enabled, but also logging and monitoring and instrumentation and error checking and all the things you need to do to be a good engineer and ship a final production app, you end up with hello world applications that are 300 lines long. And yes, the Java hello world application is already 300 lines long, but
I like to mention that.
I thought you'd like that. But like, so realistically, I don't think the answer there is hello world applications need to have all the security stuff enabled. I think it is a platform problem and also making tooling more sort of approachable, if you like.
More accessible to developers.
Exactly, yeah. So Confidentiality, I say, can pull down policies from third-party sources. If I run this, this will download those policies and actually then test them against that config file. And as you say, that was incredibly quick, including a network hop to GitHub and back.
That's pretty cool.
GitHub is obviously super fast. My network is reasonably fast. But again, that's that benefit of static analysis of declarative languages. We're not trying to solve like really complex problems. The languages are optimized for query. And we can see some of the problems that are cropping up here. Again, it's telling us where based on the policies I brought down, but we're not dropping capabilities. We're allowing privileged containers running. It's running as root. Some of the problems I highlighted earlier. I mentioned CubeSeck as well, which if I can spell, should be installed. I did not point it at the file. That is downloading an image for me.
I like that you're doing a speed test on your bandwidth right
yep.
now. Well.
It's the usefulness of working at home. CubeSeck basically gives me structured data back against a similar set of the issues we detected. So. Oh, let's head back to the slides for a moment.
So those are already like a good couple of starting point if you want to start out like building your Kubernetes security. These are like at least the basic things to figure out.
Yeah, I think so. I think there's always more you can do, and like there's lots of different facets to securing Kubernetes. There's the cluster itself. There's the applications you're running on top of it. There's the configuration that's putting it on there. One of the reasons I like sort of tools like this, especially where you're using reusable policies with Contest or CubeSeck, is you probably learn something very quickly at pretty low cost. They're fast to run, easy to integrate with, and you sort of learn something quickly. And I think they're good properties to have when you're getting started. Similarly, like moving on to Terraform. So Terraform is another great example of the sort of an ecosystem that's built up around a really great infrastructure as code tool. So Terraform is used for provisioning really any API-driven infrastructure, provisioning and managing any API-driven infrastructure. But I guess it's mainly associated with spinning up lots of infrastructure on AWS or Azure or Google Cloud. There are, again, like Terraform providers for a bewildering array of services. But firing up sort of load balancers and VMs and Kubernetes clusters, in fact, is probably the main use case. And Terraform is basically gives you a language called HCL, so HashiCorp configuration language. And that looks a bit like this, or looks exactly like this, in fact. So here we're saying, and this is a bit of a sort of cut down example, but here we've got an AWS security group. We've defined it as an ingress type with a sort of data block. We've got an ALB, basically an application load balancer setup. We've got a blank security group. We've got a managed disk and is again, you have lots of these resources in Terraform. But again, similar to our Kubernetes problem, if I said, well, how many security problems can you spot? Then the answer might be, so Liron, how many security problems can you spot?
To be honest, I think the problem is I'm not sure what I'm looking for, right? Like what can go wrong? What's the problem here?
Yep. And again, like, I think that one of the advantages to infrastructure as code is like, especially with great tutorials online, it's actually easy to get started. Like, you have to have a low barrier to entry to get adoption with technology today. But then that means that it's actually super easy for people to fire up infrastructure that might be less secure. The cloud providers, I have to say, are doing a much better job today. There's a load of sort of interesting tooling going along on the cloud side. I still think it's good if you write secure config to start with. Ultimately, having like the checks and balances works well. So a couple of things here. I mean, like, we've got wide open ingress rules. Might not be terrible, but not a great default. Unencrypted transport protocols. Again, that's probably an internal load balancer. We've heard a lot about the need to encrypt internal traffic. The idea that I think hopefully most people have now like disabused themselves of the idea that no, my perimeter is secure, everything internally is fine. Getting to the point where you're encrypting all of your internal traffic, especially in an internal network, is a lot of work. Certainly starting from Terraform, things like this are bad practices been starting out. And again, we explicitly unencrypted the storage. Now, maybe you had a good reason for that, but your company probably has a policy about not doing that anywhere. Your reason was probably something, I couldn't get the encryption working, so I turned it off. That turns out not to be a great security reason.
Very common.
So, yeah, and where you allow people to turn things off, they will do, if it makes their life a bit easier, even if it makes something else worse. And you often need those checks and balances. On the cloud side, it's actually really interesting. You've got groups like CIS, so the Center for Internet Security. So one of the things they do, and they do this across a wide range of different technologies, they produce benchmarks. So you might have heard of the CIS benchmarks. They exist for lots of different technology platforms, Windows and others. And they produce some really good benchmark documents for both Azure and for AWS. There are other ones around containers actually as well. And they're really in-depth looks at sort of common problems and what you should do about them. So each of the problems gets actually a description of, this is the problem, this is why it's a problem, and this is what you should do about it. They're really good documents. You can download them freely online. I guess the only downside from my perspective is this is what you get. You get a really textually dense document, which actually is as good a read as something like that can be, but it's a lot of stuff. So even just sort of staring at that screen for a little while, your eyes start glazing over. And that's just a subset of the index. Like the actual index of this runs a number of pages. Again, these are really good, but can we get machines to do some of this work for us? Mm-hmm. This turns out not to be a novel thought, which is great. Novel thoughts are generally often dangerous. There's actually a number of tools, even specifically just around Terraform, to help you with like this sort of security checks for your Terraform code. So one of them actually fairly recently is Terrascan. There seems to be a number of Python tools around the Terraform community, I think because of that sort of overlap with systems administrators and Python. Started a few months ago by just one chap, but it's picked up a bit of steam. It's mainly focused on AWS. It has about 30 or so rules. It might have a few more now since I looked a couple of weeks ago. And it's actually built on top of, and I like things like this as well, that built on top of a Terraform validate command, basically a library there in Python. It provides a simple CLI. It's not doing much more, but basically you can scan your Terraform code. If you're using AWS, it'll probably pick up some things that are worth investigation. Not one to probably look at, but I wanted to shout out because I like a bit of a historical record, is Terra This is actually created more than 2 years ago. Again, just to point that these ideas are not necessarily novel, but they often come around in waves. Again, didn't pick up much interest at the time, mainly focused on GCP. doesn't seem to be actively maintained, but a nice bit of the historical record. Check off more recently, again, like the last few months. It seems to be, like I said, these things come around in cycles, and maybe 4 or 5 months ago, a number of people said, you know what, we should build this, and they did that independently. Checkoff's another Python tool. Has a few rules for AWS and Azure and a couple for GCP as well. And again, provides you a Python-based CLI tool for checking your config. Again, similar sort of period of time, this time written in Go. We have TFSec. And this specifically calls itself out as a static analysis tool for Terraform code. Again, similar sort of small number of set of rules, mainly focused on AWS. Feels like there's a lot of potential to sort of centralize a bunch of these things. And there's a lot more rules in the sys benchmarks that none of these tools are checking as well at the moment. But again, some of them are pretty new. TFSec actually does a really good job of outputting useful, like actionable information. It detects problems, picks those up, gives them all a unique reference, which I think is useful, and really shows you the lines in the code that are actually causing that problem. And it's sort of clear textual descriptions of things. I think the UI for this is actually pretty nice. And again, because I'm biased and I work on Contest, Contest also is able to parse HCL, so the Terraform language, actually both the previous generation one and the new HCL2. So you can actually write your tests in Contest as well for Terraform. So here we've got a couple of examples, and I won't dig into the Rego language here at all, but you can sort of pass through and say, like, well, yeah, we're looking for any application load balancers. We're looking for any application load balancers where the protocol is HTTP, and we're going to basically invalidate those issues. And we saw Terraform like Contest running against Kubernetes files. Here you can see we're needing to be explicit about HCL2. We'll probably make that the default before we GA Contest. But another thing I didn't mention about Contest actually that I think is interesting and gets to sort of some questions you can have about like rules around config is actually Contest itself provides a built-in unit testing framework written in the same language. So you can actually write tests for your policy. This gets a little bit meta in the sense you can have tests for your policies which are checking your config. All of those things sort of being somewhat similar. So let's see a couple of quick demos of some of those tools as well. So jump over to our terminal. The sharing button disappeared for a moment. It's back. There we go.
Yep, we see it now.
So thank you. So here we've got a simple Terraform file. It's actually the one we were looking at previously. And here I've actually got the policies locally rather than downloading them. So these are some I wrote. So we've got a number of different tests there. Again, you could definitely reuse someone else's. So we can type contest verify. That's going to run our tests. So basically, that's the sort of, well, yeah, the tests we have unit tests themselves. They're actually doing the thing that they were designed to do. It's always a good sanity check. And then we can run contest test. Again, I'm needing to be explicit about the fact this is HCL2, which is the new version of HCL, which is used in Terraform 0.12 onwards. And we'll point it at our config file. And again, we're detecting a couple of issues. Again, let's go fix one of these in this example. So actually, not encrypting our disk was a bad idea. So let's enable that. And obviously our failure has disappeared. If we were to fix all the issues, we're going to exit with a non-zero status code. This makes it useful locally, especially with my terminal, but also makes it really easy to integrate into like a CI system or other tooling. Yep. Then you can have ultimately your tests run like for any changes in your code. So lots of people have been building this into their CI systems. I mentioned some specific integrations earlier. So like rounding up, and then we'll have some time for questions. And if all you take away really is like infrastructure as code is increasingly part of the application, I guess. The definitions of like words like application and infrastructure are really interesting and definitely change with different contexts. I guess what I'm meaning here is that infrastructure becoming code is often meaning that that code lives alongside the Java or the Python or the Ruby or the JavaScript code you were writing previously. The config files, the configuration languages, they're in the same repositories. Often they're going through CI systems as well. We're able to test them. And I think these are really good properties. Alongside the sort of technology parts there, though, are people. It's often the developers increasingly who are writing this config. That's a change from, I guess, 10, 15 years ago, where configuration management was definitely, I can tell you, a sort of strange subdomain in IT, where even the database people thought the config management people were strange. Like infrastructure as code is leading to its own security challenges. They're not new problems. Ultimately, we've had misconfigured firewalls and networks and application servers for as long as we've had firewalls, networks, and application servers. What code is doing is making that a lot more transparent in some ways. Before, I had to sort of, not that there's not value in looking at all of your network load balancers, for example, and saying, are they not configured? There definitely is. But if I have assurance that they're all configured according to the source code I have, then actually I can do things in a way that I couldn't before. Like looking at my 100 load balancers might be expensive. Looking at the configuration that led to those being created and managed, and is constantly making sure they're configured in that way, is a lot cheaper. There's value in both ends, but one of them can give you feedback and much faster. Especially if you're adopting something like a sort of GitOps approach, where you have that control loop fundamentally based into how you're rolling out your tooling. Testing that code makes a lot of sense. Because what we're really trying to do here isn't just find security problems. That's always good. That's always a desirable thing to do. We want to find those problems earlier. By finding them earlier, we can ultimately fix them before they're in production even. As things change, we can fix them with the people who are making writing that configuration in the first place. That reduces communication overhead. It reduces that sort of gap between like thinking you've done something and needing to go back to it. All of that really speeds things up, because ultimately we don't want to be writing configuration all the time. We want to be writing our application, because that's the valuable thing. So thanks for listening. Again, shameless plug for Sneak, where me and Laurent work. But if you're interested in any of these topics, please do ask any questions now, or we'll jump into the Slack channel for questions there as well. And thanks for listening.
Awesome. Thanks, Gareth. This has been interesting. And I think the recap of all the tools is really valuable, understanding that there's several options that you can start with. It's pretty cool.
I think it's ultimately an emerging space. I think that it's not novel, but I don't think we talk about configuration security. People have started building tools. I think we'll hear a lot more about it, especially as we observe like democratization of that infrastructure as code, at the same time as a realization that it's not the fact that the cloud is secure that's going to get you. It's the fact that you configured the cloud insecurely that's going to get you.
Right. The thing that's basically the human error kind of cause of it.
I think it's, again, blaming it on human error feels like it's sort of the person's fault. Ultimately, it's like we have, as humans, we talk to computers using programming languages. None of them are perfect in the sort of perfect sense of it's impossible to write an insecure application. And you can argue pros and cons of different ones, and that's true of configuration languages as well. But I think it's a property of software development, of software engineering today, that you're not going to get security for free. So you have to think about it. I think how we address that is awareness. If you think, oh, I haven't thought about, if you think I haven't thought about this before, then you're not going to fix it. If you think, oh no, I've thought about it now, what should I do? The nice thing is people are starting to build tools, and that's, I guess, how as an industry we address some of these issues certainly in the short and medium term.
Yeah, I totally agree. We're all like part of this ecosystem, so we're helping each other, building the right tools. Cool. So heading off to the live session, we have a question from Hazana on if you have any insight or like gauging like rate of false positive for static tools for like configuration languages. Is there anything that you have seen like from Puppet or maybe?
So no, actually, I think it's I think for the most part, the tools are focused on quite explicit sort of issues. The sys benchmarks do a pretty good job. I guess one of the things here that make it a bit different to like, is this a vulnerability or not, is context matters a little bit. Good example might be the encryption thing. Sort of on a general rule, don't do that. Don't explicitly unencrypt your disk when that cloud platform is going to give you like encryption literally because you said true. That is an amazing, I mean, like encrypting disks, like as a sysadmin and like actually managing the infrastructure to do that at scale is difficult. The idea that you can get this because you put a Boolean is amazing. Throwing that away, I think, is nearly always the wrong thing to do. The issue there isn't that it's a false positive and I've detected something that's not happening. The issue there is you might have a business reason to do so. I think in those cases, that's about having tooling that allows you to not willy-nilly ignore things, but ultimately
adopt maybe.
Well, it's that sort of like when you get out of sort of very specific security domains, you very quickly got into risk, and you start talking about what risk is and where you're going to accept that risk. And sometimes you can go too far and simply say, yeah, just give me a number and I'll accept all the risks. I think the issue here is it's highlighting something of interest. I don't think a lot of the tools are mature enough to really have gone through that sort of generation of these rules are more valuable than others. As I said, some of them they have a small number of rules. I think what we're going to see is this interest over time. We'll see tools have a lot more rules. We'll have a lot more examples to go on. I'd love to see a conversation about configuration security in general, not just the individual tools. And I think from there we'll get into conversations of. I don't think it was false positives. I think about it in terms of which ones are more likely to be like sort of actually okay from a company risk perspective. Yeah, it's definitely a good question, especially I think like touching on like it feels like a question that touches on a history of static analysis. I think declarative languages remove a lot of the is it or not problem from static analysis. It doesn't mean that everything is a security problem to you, and I think that's the interesting area.
Yeah, context is always an important thing. All right, so I think we're going to wrap up. That's all the time we have for today. Thank you for all the questions, and a huge thank you to Gareth for joining us and delivering this talk. Thank you everyone for joining us as well. I hope you enjoyed it. Our next session is going to be in 2 weeks on March 19th. Will be about vulnerability scanning for container images with Liz Wright from Aqua. You can get your tickets, just sign up for it and also be on the MyDevSecOps.io website. In the meantime, if you enjoyed the session, you're welcome to share the video and reach out to us on the MyDevSecOps Slack community. So we're all there, just ping us. So thanks everyone. Thank you, Gareth. Thanks everyone for joining us. Have a great day. Bye-bye.